Hello, my name is Brett Bell, and this is Spectroscopy of an Unknown. To set up the situation, the train that runs through Alliance, Ohio, has just derailed and spilled an unknown chemical all over the place. Authorities must act quick to determine what the solution is. To do this, they will use the IR and NMR graphs of the solution. This will help them determine what the solution could be. Both measurements measure the amount of electromagnetic radiation absorbed by the solution. So this is an example of an IR graph, and this is an example of an NMR graph. First, I'll talk about the IR graph. The IR graph is also known as our infrared spectroscopy. According to our Chem 120 lab manual, it shows the functional groups present by the absorption of a photon in a specific infrared region, which creates a large energy of molecular vibration or wavelengths, and this is measured in inverse centimeters. So these are the possible functional groups that are shown by the IR graph according to our lab manual. There's an OH bond, which is in the range of about 3,500 to 3,100. There's a CH single bonded benzene ring from about 3,150 to 3,000. There's a CH singly bonded carbon from 3,010 to 2,800. A C double O bond from 1,750 to 1,650. A CCl bond from 850 to 600. And a CBr bond from 650 to 550. Next is the NMR graph. It is also known as the nuclear magnetic resonance spectroscopy. According to our Chem 120 lab manuals, it shows two things by absorbance of a photon in radio frequency region, which then excites the hydrogens. So when these hydrogens are excited, two things come about: how many different types of H's there are, and the relative numbers of each one. This narrows down the possibilities greatly when it is combined with the IR graph results. So here is my IR graph of the solution. As you can see here, we have 3,339.32 centimeters inverse, which is in the OH bond range. We have 2,974.63 centimeters inverse, which is in the CH single bonded carbon range. And over here we have an 803.78 centimeters inverse, which is in the CCl bond range. This isn't as strong though, so we're not going to worry about it, and it's not relevant to our solution. There are also other peaks here, but they are not in ranges that affect us in Chem 120 right now. So this is my NMR graph solution of the solution. We have three peaks, so we know that there are three different types of H atoms. And the first peak has a 1.0 ratio, so there's 1 for the ratio of that. 1.87 is our second peak, so we round that up to 2 because we need to have whole numbers in our ratio. And then our last one is 2.90, which we would round up to 3. So what this graph tells us is that we have three different H atoms with a ratio of 1 to 2 to 3. So these are the results of my two graphs. The IR graph limits the possible molecular structures to methanol, ethanol, T-butanol, and 2-propanol. As you can see, methanol has the OH bond right here and the CH single bonded carbon right here. Ethanol has the OH bond right here and the CH bonds right here. T-butanol has OH bond here and the CH bonds right here. And 2-propanol has the OH bond here and the CH bonds right here. So this shows that these four, because the IR spectroscopy, could be possible molecular structures. But when we look at the NMR, it limits us to just ethanol, because ethanol has three peaks, which are the three different types of H atoms. This is 1, this is 2, and this is 3. And they each have a ratio of 1 to 2 to 3. This says 3 H's, this says 2 H's, and this says 1 H. Methanol has just two different types of H's, so it would have 2 peaks. Butanol has two different types of H's, so it has 2 peaks. And 2-propanol has two different types of H's, so it would have 2 peaks. So the only one that has all the functional groups and the NMR results is ethanol. So now that we know it's ethanol, what are some possible uses of ethanol? According to Donald O'Leary at the University of College Cork in Ireland, ethanol is used in the manufacturing of alcohol. It is used in about 95% of the manufacturing of alcohol. Ethanol is also used in the use of gasoline. According to ConsumerEnergyCenter.org, it is used in small quantities of about 5 to 10%, on average it's about 6%, and it can be used as high as up to 85% in E85 gas, but a car has to be manufactured to handle that much ethanol. So now, let's summarize what we've talked about. We had an unknown spill, and we used the IR and NMR graph results of it to determine what the solution could be. The IR gave us the possible functional groups, and the NMR gave us the possible H atoms and the different, or how many relative ratio of those H atoms. Once we narrowed it down, we determined that they had a CH bond and an OH bond, so it could possibly be ethanol, methanol, T-butanol, or 2-propanol. And then finally, when we looked at the NMR, we determined that it had 3 different H atoms and a 1 to 2 to 3 ratio, which is seen here in the molecular structure. These, of course, again, are my 2 graphs. These are my resources, and that is the unknown spectroscopy. Thank you.